Greetings, class. So we left off in the last video. We were talking about making some measurements of happiness. I'm going to ask people to indicate their level of happiness using a Likert scale from 1 to 10 and 1 to 100, just like I asked you to think about in the last video. So I did this for an entire class. In fact, I did it for 3 classes. And so I sent you some data to look at. It's kind of nice to use actual data instead of just examples from the textbook. We'll use some made up examples, but this is some actual data. So hopefully you've had a chance to look at it. It looks something like this that I sent you, and I just want to point out a few things. This is for an 830 section, a 930 section, and a 1030 section of statistics. And there are 2 columns for each class. One is the Likert scale from 1 to 10, and then I had the same people give me Likert scale 1 to 100 in terms of their level of happiness. What I want to pay attention to for our initial analyses here is the Likert scale from 1 to 10. Okay? And we're going to combine all 3 classes. And so what I want to ask you, another thing, let's look at the numbers a little bit. Data always provide you with information, okay? And there's a couple of things that I want to point out here just as we get started, because I'm going to have you change some of these numbers, believe it or not. I usually don't change data. The data are the data, right? We got to deal with them. But for the case of, we're doing this for instruction, I want to make it, as straightforward as possible. You see a couple of things. 2 people, this person here, said 5.5 on a Likert scale from 1 to 10. Okay? So I had people respond just on a piece of paper, not, filling in a bubble on a test sheet or something like that. This person also gave me a 0.5, 8.5. Okay? Now, that's just a little factoid that those 2 people gave me something other than a whole number. But this tells me something about the variable of happiness. It tells me something about the variable of happiness, okay? The fact that this person gave me a 5.5 and this person gave me 8.5. It's telling me that this person said that they're somewhere in between 8 and 9. This person says, I'm somewhere in between 5 and 6. By the way, I would also not assume that they meant 5.5 exactly, or 8.5. What they're telling me is they're between 8 and 9, or they're between 5 and 6. Okay, because I always see students respond. A couple of students respond this way, but I've never seen someone respond by saying 7.3 or 9.2. It's always 5.5 or 8.5, which to me is telling me it's somewhere in between. Okay? Now, what does this tell us about the variable of happiness? Well, to me, what it says is that my contention in the last video that happiness is a continuous variable, there's some support for that because it doesn't come in chunks of whole numbers, okay? And by the way, when we talk about continuous and discrete variables, we're talking about the nature of the variable, not the nature of the measurement, okay? So even though we're doing a Likert scale from 1 to 10, for example, it doesn't mean that happiness comes in packets like that, even though we're measuring it in whole numbers. Okay? And if you had to fill out an IBM sheet, with the little bubbles in it would be difficult to put 5.5 or 8.5. that doesn't change the nature of the variable. So happiness is a continuous variable no matter how we measure it. Okay? Another thing that tells me that this variable is a continuous variable is when I ask people to go from a 1 to 10 Likert scale, and I ask the same people to tell me their happiness on a 1 to 100 Likert scale, sometimes, if it was just a straight up mathematical relationship, somebody who said 8 would then say 80, someone who said 7 would then say 70. But look what happens here. Some people who say 7, they've written 77. Or when they say 4, they've written 48. Or when they say 7 here, they said 65. So that's another indicator that when we ask people to indicate their happiness on 1 to 10, it's not sufficient as a measurement to indicate their level of happiness. Okay, so both of those things give me an indication that happiness is a continuous variable. Of course, when you think about happiness, it's just at face value, it seems like it would be a continuous variable. But certainly these data reinforce that notion. Okay. Now, for the sake of this class, what I want to do here is I'm going to change the 5.5. I'm going to change that to a 5. Okay, so let's just cross that out. I'm going to cross the 5.5 out, and I'll have you do the same. Just make it a 5. The reason that I'm going to 5, even though they said 5.5, is because when they rated their happiness on a scale from 1 to 100, they made it a 50. So I'm going to make this a 5, okay? Now when we go down here to the 8.5, when they did the scale 1 to 100, they went to 85. Since I took off a half here, I'm going to add a half here. So I'm going to change that to a 9. Okay, so if you could do that too, that would be great. Then we have all whole numbers. Okay, I took away a 0.5 here. I'm going to add a 0.5 here. That means the total for this group is going to be the same, right? That's one of the things that is sort of nice. I haven't changed the overall total. I haven't changed the average for the class. But I'm going to make this whole numbers. And there's a reason for that. It'll make it easier for us to do our initial descriptive statistics. Okay, so here's the question I have for you, because I'm not interested in telling you what to do all the time. I would like you to think about, what is our goal? What is our goal for descriptive statistics? Well, pretty straightforward. We would like to describe this data set. And again, this data set is actually larger than what we're normally going to do for this class. We're normally going to do very small data sets to make it easy, or easier. But this is a more realistic data set. It's got quite a few numbers, even though we're gonna not talk about the 1 to 100 numbers. We're going to talk about the 1 to 10. And I would ask you then, what could we use to describe this data set? Okay. Again, if you go into your supervisor and the supervisor says, hey, and by the way, you could be the supervisor, right? I don't want to look at all of these numbers. Can you sort of summarize this data set? And sometimes I use the word distillation, and I don't know if everybody's familiar with that term. We're going to distill a large amount of information, okay, this data set, and I'm going to try to describe that using a smaller set of numbers. Okay? So let me ask you this. How would you describe this data set? I mean, just how would you start? Okay? And let's start from kind of a real basic number, and that is I want to tell you, I'm going to describe this data set by saying, well, how many numbers are there in this data set? Okay? And we're going to give that descriptive statistic is going to be given by capital N, that is the number of items in the data set. Okay? If this were a sample, I'd use little n, lowercase n, to describe it. For right now, we're not going to worry about samples. We're going to say, listen, I'm just interested in this group of numbers, and so that becomes then a population, okay? And I want to tell you, how many numbers are we talking about here? And how many numbers do we have in this data set? And you'll be able to, count those. We have 61 people that responded, okay? 61 is our N. Now, I think that this is a valuable descriptive statistic. Most stats books don't refer to N as a descriptive statistic. It's just, they just say, well, it's the number of items in your data set. But I think it's helpful for me as a researcher or as a supervisor because it tells me this is the number of people that responded. I would think differently of the data set if N were, 21,617. Wow, that's a lot of numbers, okay? I might think a little bit differently about the data set if this was only N equal 5. That means pretty small, okay? So looking at the number is actually the beginning of our description of what's going on in this data set, okay? N equals 61, 61 people. Now, what else might we use to describe this data set? Can you think of different ways to describe the data set? Now, sometimes when I ask that, people are just sort of sitting there waiting for me to give you the answer. I'm like, no, let's be part of this. Okay, let's be proactive. And I'm going to ask you to think about the last time that you wanted someone to describe a data set for you. What were you looking for from them? And of course, some of you are thinking to yourself, I've never asked anybody to describe a data set to me. I'm like, that's where you're wrong. That's where you're absolutely wrong. You probably did it last semester. Like, what? Well, when the teacher comes into the classroom and they hand back the first exam, what is one of the things that you want to know? Okay? You want to know, what was the average on the exam? What was the average? Right? What you're asking the professor to do is to describe the data set. Notice what's happening here, right? As soon as I say data set, people think I'm talking about statistics. This has to do with a statistics textbook, and this is hard, and I have no idea what's going on. And I like to break through those barriers because they're sometimes can be silly, okay? You certainly want to know, what does the class look like in general? Notice that you don't ask the professor to see everyone's exam score, although that might be helpful, right? What you ask about is the average. So let's do that first. Let's do average, okay? And in statistics, the average is called the mean. When I use these three, like an equal sign with 3, that means sort of by definition or in other words or something like that. The average is the mean, okay? I'll be using those terms interchangeably. I don't know, to tell you the truth. There might be a difference mathematically, but I'm not sure there is. So let's get the average. So do you know how to get the average for a group of scores. I hope your answer is a big fat yes there. And let's look at the recipe for getting the average. Now, the mean in statistics is going to be given by this symbol. It's a mu, mu, okay? It's a mu. By the way, you can use that word in Scrabble, just saying. Mu. It's like a U with the tail in front, okay? That denotes the average. Now, do you know the recipe for the average? That's correct. You add up all the scores and then divide by the number of scores. Well, I want to do this in symbols because I want to make this a generic formula that can be used for all data sets that we have, okay? In this case, let's do this. So divide by the number of numbers. So we know that symbol. That's the one I gave you here, right? But I want to make this a generic formula so that this is the formula we'll use whenever we're looking for any averages, whenever we're looking for any means, okay? And what are we going to do? We're going to add up the scores. Well, each score, the symbol for the score, the data point, the individual, is X, okay? We're going to subscript this. So you take the score for the first person plus the score for the second person plus the score for the third person plus the score for the fourth person. We better make this a little bit longer, okay? Plus the score for the fifth person plus the score for the sixth person plus the score for the seventh person plus the score for the eighth person plus the score for the ninth person, and so on and so on. Okay? I mean, that's what you said, right? Add up all of the scores, divide by the number of scores. So we're going to add up all the scores, divide by the number of scores. Well, I think you would agree that this is a cumbersome recipe. And in fact, it will go out to 61 for this example, but if we had 21,000 points, we'd have 21,000 X's, and if we had 16 points, we'd have 16 X's, and so on and so forth. It's very cumbersome, and it's specific to this data set. If we go out to 61, we're going to be doing a lot of work with means, with averages, and so I want to come up with a better formula here, and I'm going to promise you that formulas that we use, the recipes, we're going to try to make them as simple as we can. And if you don't understand why we're using the symbols that we're using, then email me a question or ask when we get onto Zoom or whatever. This is cumbersome. So, and we're going to do a lot of this mean stuff. So I'm going to change this recipe, okay, to make it less cumbersome. Certainly, we're going to have the number of numbers in our denominator. But in the numerator here, I'm going to use this symbol. It's a sigma, folks. It's not an E. Once in a while, I'll have a student ask me a question. I'll be like, well, what is that E thing? I'm like, I don't know what you're talking about. Listen, that's a sigma, okay? It looks like this instead of a E. It's sigma. It's uppercase. It's a Greek letter. So if you see some sororities or fraternities, you might see this symbol if they have sigma in their name. Sigma X, okay? Now sigma is called the summation notation. The summation notation, okay? That means add up all the X's. Okay, now whether we have 61 or 12,000 or 27 or 4 or 4,800, This is our generic formula. Add up all the x's. So in our case, we're going to take our 61 numbers and we're going to add those together, okay? And then divide by the number of numbers. So we already know what this is. This is 61. So let's add up all 61 numbers, okay? Let's do that right now. And I'm going to have you pause the video because it's going to take you a little bit of time to add those numbers up. You should always do it twice. You should always do it twice because you can always make a mistake, okay? And even if you do it twice, you can make a mistake. Again, once we get out of this class, we'll be doing it with a computer, but I'm not going to do it with a computer right now. I'll show you how to do that, but it's good for you to get some practice in math. So I'm going to have you pause and let you add up all 61 numbers, and we'll get the sum of all the x's. Okay, so pause now, and then you can come back to me when you're done. Okay, did you get it? It is 428 for our total, I think. Let me just check this, okay. If you, hold on, I'm going to get this. I just want to make sure, since I'm the teacher. Okay, so yeah, 428 is our total. And so 428 divided by 61, and that gives us an average of 7.01639 or something like that, okay? I'm going to ask you, well, I'm going to demand of you, since I'm the teacher, we're going to go to 2 decimal places as a matter of habit in this class. We're going to go to 2 decimal places as a matter of habit, okay? You guys use 2 decimal places all the time. And once again, people are like, I don't use 2 decimal places all the time. I'm like, of course you do. It's called money, right? That's 2 decimal places. So we're going to go 2 decimal places, and I'm going to have you round appropriately. This is something I was confused about because some students were having a hard time with this. I'm not asking you to truncate it. That is, I'm not asking you to just cut off the 3rd decimal place. In this case, if it's 7.016, then to go to 2 decimal places, our answer would be 7.02, right? Because this is larger than 5. So we're going to round up in that case. So our average is 7.02, okay? The mean, mu, 7.02. So we can put this up here. Okay, 7.02. And that is just like what a professor would do when they tell you average for the class. This is the formula that is used. So we now have 2 descriptive statistics so far in our toolbox. We're going to have a whole toolbox full of different statistics as we make our way through this class. Okay? 7.02. By the way, 7.02 is not the same as 7. Okay? It's 7.02. Later on in the semester, I'll show you how something like this can make a big difference if we're talking about really large numbers. So let's retain 2 decimal places, okay? 7.02. Here is probably the most difficult question, one of the most difficult questions in statistics. Really strange. I'm going to say, okay, you can calculate the average. And I'm sure you've done it, right? The average for your 3 exams in a semester, the average for your paper scores, the average for your running speeds if you're in track, the average for your points per game, you know, if you're a basketball player, the average temperature for July, all of this stuff, right? You've heard it a lot. You've done averages for years, right? But here's the hard question. We can calculate it, not that difficult, okay? But what does it mean? What does it mean when I say the average is 7.02? I would bet $100 that none of you know that, okay? Because it's a very difficult question. And by the way, when I say what does the average mean, well, the average is the mean, or what does the mean mean? The mean is the average. Well, all you're using there is a synonym. The conceptual meaning of the mean is very difficult. And in fact, it's an unfair question at this point. But I'm going to tell you the difference between mathematical stuff here. Like, we just calculated that, okay? You could have made a mistake adding up the scores, but once you get that, you just use your calculator, you get this value. On the exam, I'm going to ask you, well, what does the mean mean? And we're not quite there. We haven't gotten there yet, okay? But we'll get there, okay? If a professor comes in and says the average on the first exam was a 75, then what does that mean to you? Now, some people say, well, that's the middle score. And I'm like, not necessarily. Some people say, well, that's the most common score. I'm like, definitely not, okay? What does it mean? Well, unless you make a bunch of assumptions, it's you probably don't know what it means. And let me ask you this question. Because sometimes the problems sort of help you understand that we don't really know what the mean means at this point. What if the professor came in and said, hey, the mean on the first exam, the average on the first exam was a 75. And usually people are like, oh, okay, all right, okay. Well, if everyone got 75 in the class, do you know what the average would be? That's right, it would be 75. Probably not what we're assuming, but if the professor comes in and only says, hey, listen, the average on the exam was a 75, that could very well mean that everybody in the class got a 75. Okay? So it's like, well, that's weird. If the professor comes in and says the average on the exam was a 75, well, if half the people in the class got a 65 and half the people in the class got an 85, then the average would be 75. Let me say that again. If half the class got a 65, that is, half of the class got a score of 65, and half of the class got a score of 85, we would have a mean of 75. It's like, oh, yeah, that's right. So when the professor says 75, how do you know that not everybody got 75? Or how do you know that half the class got 65 and half the class got 85? You don't know given the mean itself. If the professor came in and said the average for the class was a 75, it could be that scores went from 10% up to 100% and everywhere in between, right? And we could get an average of 75. So from the average, it's hard to know what's going on with the entire data set. Everybody with me? If a professor comes in and says the average on the exam was a 75, you don't have any idea whether everyone got 75. That's one possibility. Maybe everybody either got 85 or 65. That's another possibility. Or the scores were all over the place. That's another possibility. Or scores were all in the 70s. Could we get an average of 75 if all the scores were in the 70s? Of course you can, okay? So it's very weird. I mean, in our case here for our data set, as long as the total for the scores is 428, we're going to get this average. Could we get a value of a total for 428 if all the scores were between 7 and 8? If all the scores were between 7 and 8, or in this case 7 or 8, could we get a mean of 7.02? The answer is yes. Could we get a mean of 7.02 if the scores were between 4 and 9? The answer is yes, as long as the total was 428. So this is really all of a sudden causing us a little bit of problems. And I hope that the next time when you ask the professor in class, what is the average, that you're not just satisfied with that information, because you don't know if scores are all over the place or if they're really right around the average. In the example I was talking about before, an average of 75. So that's a problem. And I'll be raising these problems as we go through the semester, because it's a problem and we need to deal with it. Is there a way that we can know a little bit more about this average given the distribution of scores in the data set? And the answer is, hells yeah, we can. Okay. We can get that information. Let's go back to that example. And I want you to think about this a little bit. Think about it a little bit, right? Professor says the average is 75. What question might you ask to help you understand the data set a little bit more? Whether all of the numbers are 75, whether they're really spread out, whether they're really all in the 70s or whatever. Well, one of the things you can do is you can say, well, what was the highest number? What was the lowest number? Like, tell me something about the spread outness of scores, right? And in fact, that's the reason that we have another descriptive statistic to help us understand what's going on here with the mean. And that other descriptive statistic, or another descriptive statistic, is called the range. Okay? The range. Now, let's look at this data set here. And if we look and we say, well, what is the highest number that we have? And then what we're going to do is subtract the lowest number. Okay, so what's the highest number in this data set? What is the highest number? Let's take a look. Well, there's a 10. So we have a 10, and the lowest number is a 3. Okay, so that means that we have a range of what? Of 7. Okay, now, again, pretty straightforward. Take the highest, subtract the lowest. Okay, 10 minus 3 equals 7. But once again, I'm going to emphasize this, and I always do. Folks, please pay careful attention to what I say, because I'm very deliberate, and I'm going to be making up your exam, so pay attention to what I say is important. Now, pretty easy computationally, same thing here, right? The mean is pretty easy computationally, but I'm going to say, what does the mean mean? And I'm putting that on hold for a couple of videos from now. You can do the computation. Likewise here, we can do the computation, but I'm going to go further in terms of the concept, and I'm going to say, well, what does the range mean? Okay, what does the range mean? And here's what the range means. I'll say it twice. You can go back and listen to it again too on a video. The range tells you the number of units in a number line across which the data set traverses. That is, how much distance along the number line do our numbers, do they fall into? That is, how much of the data set do they traverse? Okay, so let's do some fingers. Let's do some fingers. Okay, so we had a 10, we had a 9, we had an 8. By the way, even if there were no 9s, this would still be our range. Okay, it's the highest and the lowest, even if we're missing some values. But here we go: 10, 9, 8, 7, 6, 5, 4, 3. So the numbers, this data set, go across 8 units in our number line. Okay, so the range is 8. Oh my gosh. Let's check that again. 3, 4, 5, 6, 7, 8, 9, 10. The range of numbers in our number line across which our data set covers actually is 8, not 7. Don't worry, folks. I did this intentionally. I do it every semester intentionally, okay? Take the highest minus the lowest, because some high school teachers will actually tell you this is the range, 7. And that is incorrect. It's patently incorrect if you know the concept of the range. The range tells you how many units in a number line the scores go across. Okay? 10, 9, 8, 7, 6, 5, 4, 3. Okay? So what we're going to do here is we're going to add 1. Okay? It seems a little bit arbitrary. I will cover that a little bit more in the next couple of videotapes. Okay? So we're going to add 1 here. Our range is 8. And another thing to remember, and I'm going to remind you again, I hope that you're taking notes. You should be taking notes when you're watching these videos. Please don't watch these videos like you're watching Game of Thrones. Okay? You need to take notes because I'm going to ask you specific things during the exam. The range is a single number. In statistics, the range is one number, okay? And that's because the range tells you how many units across the number line the data traverses, okay? We get that number by taking the highest, subtracting the lowest, but we need to add 1 because we're not looking at the difference between 10 and 3. 10 and 3 need to be included in the range, and so we're going to add 1, okay? So the range is highest minus lowest plus 1. That's the computation. The concept is this is the area on the number line. This is the number of units the data traverses. Okay, the data goes across is what I'm talking about. Now, BFD, right? Big fat deal. I mean, what does that tell us? Well, listen. For our data set, could we have gotten a mean of 7 if all the numbers were between 7 and 8? The answer is yes. Could we have gotten a mean of 7.02 if all the numbers were between, let's say, 5 and 8? The answer is yeah. Could we have gotten a mean of 7.02 if the numbers went from 1 to 10? The answer is yes. How do we know which of those possibilities is the actual case? Right here. This tells us these numbers, the data, go across a wide range here, 8 units. So we know that this didn't just come from 7s and 8s. This tells us more about this, okay? And so one of the questions I ask sometimes on an exam, I say, what does it mean when I say the range informs the mean, okay? Well, this tells us a little bit about the spread outness of the scores. The scores go across 8 units and we got a mean of 7.02. If all of the scores were between 7 and 8, if all of the scores were between 7 and 8, what would our range be? Let's take a moment, right? I'm looking at my data set. 7, 7, 7, 8, 7, 7, 7, 7, 7, 7, 8, 8, 7, 7, 7, 8, 7, 7, 7. What would be the highest? The highest value would be 8. What would be the lowest? The lowest value would be 7. So the range would be 2. When I report this, if I said the range was 2, then you would know, wow, this comes from all numbers that are really close together, okay? If it gets 7.02, my range is 8, then I know this. We have a lot of spread outness in our scores. That is, they cover a large range, a range of 8 versus a range of 2, okay? Now, we do have to be careful because the range also is lacking a little bit, because we would get the same range if the scores went from 9 to 2, right? We'd have the same range. If the scores went from 8 to 1, we would have the same range. So I like to also report the highest score, report the lowest score, report the range, report the mean. We tell people this came from 61 observations, okay? So we have 1, 2, 3, the range, 4, 5 different descriptive statistics already, okay? And sometimes people will be like, whoa, why is it so complicated? Why is it so complicated? No. We're not creating complexity here. We're trying to understand that this mean can come from a lot of different data sets. A mean of 7.02 can come from data sets that look very different. All 7s and 8s, numbers from 1 to 10, numbers between 5 and 9, and so on and so forth. Everybody with me? 61 people. This is our mean. The highest that anybody, highest happiness anybody reported was 10. The lowest was 2. There were no 2s and 1s. That's a good thing. The range was 8. That is 10, 9, 7, 6, 5, 4. 10, 9, 8, 7, 6, 5, 4, 3. Okay? 3, 4, 5, 6, 7, 8, 9, 10. That it went across 8 units in my number line. A lot different than if it just came across 3 units. This informs this. This tells us a little bit more about this. This tells us how many went into this average. We have our highest, we have our lowest. Okay? All right, what else? What else might we want to know about the data set? And I know some of you have had this stuff in high school. And so let's see, we have the mean, right? We have the range. Let's put those in here. Range is 8, okay? I said 2 decimal places, so we can do this, okay? Please remember that zeros are numbers and they have meaning. If you don't believe that zeros are meaningful, try putting an extra 0 on your paycheck. See how that works out. Okay? Or instead of $200, your boss pays you $20. You're like, hey, what's going on here? And the boss says, well, zeros don't matter. Zeros matter. Zeros matter. Let's do 2 decimal places. Okay. What else? So we have the mean. We have the range. What else might we want to know? Somebody might say, well, what about the mode? Okay. And I'm like, yep, that's one of the primary descriptive statistics, the mode. And what does the mode mean? The mode means the most frequent score, or the most popular flavor of ice cream would be the mode, if we had categories. But it's the score, it's that data point that we see most often, okay? Mode, like pie a la mode, right? You put the ice cream on top. That's the highest, most frequent score that we see in a data set. So let's take a look at our data. And what is our mode equal to in this data set? What is our mode equal to? Okay, let's take a look. What's the most frequent score? What's the most frequent score? Everybody got it? You might have the wrong. If you thought it was 7, no, it's not 7. Our most frequent score, oops, hold on now. Our most frequent score is what? It's 8. Okay. Our most frequent score is 8. So that is the score that people reported the most in terms of their happiness. Now, I will put 2 decimal places on here only because I'm trying to get my students in the habit of using 2 decimal places, even zeros. In this case, however, because there's a concept here, there's a concept that follows the numbers. In this case, technically the mode is 8 without the decimal places because nobody reported a score of 8.00, right? This is not a calculated score. This is the actual most common score, or most common happiness level. So technically it's 8, but this is how important I think going to 2 decimal places is. If you put that down, I'm okay with that. Technically it's 8, okay? So mean, mode, range, number of subjects. Let's put our highest score in here too. Let's put our lowest score in here too. Okay. And we have quite a few descriptive statistics. This is not meant to make things more complicated. This tells us more about this. This lets me know the size of the data set we have, 61, okay? Most frequent score. This is going to relate to probabilities, right? If we took all 61 scores, put them on little pieces of paper, individual papers, folded them up, put them in a big box, shook up the box, I pull out a piece of paper. What do you think the number is on this piece of paper? What would be your guess? And sometimes people are like, oh, I don't know. No, I'm asking you to guess. I'm asking you to guess. What would your guess be? 8. My guess would be 8 because that's the most frequent. There's more 8s than any other response. So if I pulled one out at random, my guess would be 8. Could I be wrong? Absolutely, I could be wrong. But I'm going to maximize my guess. Okay. So I know some people were talking or were thinking, what about the median? Okay. People say, well, what's the median? All right, what's the median? And we'll get to that in the next video. All right, for now, we'll stop and then we'll start and we'll talk about, we'll get to the point where we talk about the median.